All right, guys, so we're going to go on and go through the review sheet. We're going to get through as much of this as we can. Your test, the first part of it is tomorrow, which will be dealing with pretty much everything, factoring, solving by graphing, solving all the solvings by the different methods. Now, we're going to go through as many of these as we can. I'm going to try to get through as much of it as we can. If there's something that we don't cover in class, I have already uploaded a video of the entire review sheet. So I stayed late yesterday and did every single problem from the review sheet already. So it's already up there that you can go back and watch if we miss something that you figure out later that you want to see done. So the first thing we're looking at is factoring. So we have 1 through 12 with factoring. Are there any questions on 1 or 2? Either one of these here with factoring. I'll go on and just look at number 1. So when we look at this here, whenever we factor, when we're factoring 2 sets of parentheses, the first thing we look for is a greatest common factor. So if I look at these 3 terms, we're looking to see, is there something that will go into all 3? And that would be 7. And if we factor the 7 out, 7 out of 7b squared is just b squared. Minus, if we factor 7 out of 63, we have 9b, and factoring 7 out of 140 is going to be plus 20. And really, when we factor that out, we're just dividing the number by whatever the greatest common factor is. Now, we could factor out a negative if the number in front of b squared or whatever the variable squared is negative. We can pull it out too. Now that we have that, we'll have 2 sets of parentheses with 3 spaces, which is step number 2. Our third step is the sign, and we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Well, here the third term is positive, so the signs are the same and they match the sign of the middle term. So we'll have negative and negative. Our step number 4 is the factors of the first and third term. If there's only one set of factors for either the first or third term, we'll go on and just plug them in. Well, the only factors for b squared are b and b. Now the factors of 20, there are several. We have 1 and 20, 2 and 10, 3 doesn't work, but 4 and 5. 4 and 5. And the last thing we do when we check is, the last thing we do is to check. And we could do the whole check. We can multiply everything out, do b times b, and -4 times -5. But the main ones I check is b times -5 is -5b. -4 times b is -4b. And -5b minus 4b is -9b. And that would be that there. And that'd be our final answer. Any other questions on this one here? Yes. So when we look at number 6, we first, again, look for greatest common factor. And between 3, 11, and 6, there's not one. There is one between 3 and 6, but 11, unfortunately, does not divide by 3. However, there is a greatest common factor I would pull out, and that would be the negative. I would pull the negative. If there had been a number that was in common with it also, I would have pulled it out too, because I want to try to keep the variable that's being squared positive. So 3 factored out of -3t squared is just going to be 3t squared. When I factor a negative out of positive 11t, it's going to become -11t. And when I factor a negative out of -6, it becomes positive. When we factor a negative out, we're flipping all the signs. And I didn't say this on the first one, but you do need the greatest common factor as a part of your answer. So here we would need the negative as a part of our answer. Now, After we set it up, we're looking for the sign. So we look at the third term. If the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite. Here it's positive, so the signs are the same and they match the sign of the middle term, which would be negative and negative. Now we need to find the factors of the first and third term. Well, the factors of 3t squared, well, t squared is going to be t and t. That's the only factors of t squared. The only factors of 3 are 3 and 1. So I'm just going to put a 3 in one of the two spots. We don't have to put a 1 because 1 times t or t are the same thing. Now we need to look at the factors of 6. Well, that'd be 1 and 6 or 2 and 3. It would be 2 and 3. Which one do we want to put first, the 2 or 3? 2, 3. And as we kind of went over in class, I can't put the 3 with the 3t because 3t and 3 would have a greatest common factor of 3, yes? If there's not a greatest common factor to begin with, there's not going to be one in either spot. If you notice that there is no way to set it up without a greatest common factor, look back at the original one and see if there is one, because there might be one we missed. But here, 3, 11, and 6, there's not one, so 3 and 3 can't go together. And if we check this, 3t times negative 3 is negative 9t. Negative 2 times t is negative 2t. And negative 2 minus 9, or negative 9 minus 2, is negative 11t. That is what we wanted. So this here is our final answer. And we do need the negative as a part of the answer. Because we factored it out, it's still a part of our answer. Any other questions on this here? Okay, questions on 8 or 9 or 10? 8, 9, or 10? 8, 9, or 10? 10. Now, 8, 9, and 10 are all similar in that they're all a difference of perfect squares. Because whenever we have two terms being subtracted, we do need to check to see, is it a difference of perfect squares? And if we look at 10, a squared is a perfect square because it's a times a, yes? 25b squared, well, 25 is what? 5 times 5, and b squared is b times b. And the difference of perfect squares, a squared minus b squared, was a plus b times a minus b, where a and b are what we need to multiply it by itself, or what's multiplied by itself to get our term. So we'll have our plus and minus. So what multiplied by itself to give us a squared? Well, it was a, yes? So in the first spots, we would have a and a. For 25b squared, well, that was 5b and 5b. And that's it. Yeah. And you could check it if you want to make sure we got it set up right, because is there a middle term? No, so if we check it, the middle term should be 0. A times negative 5b is negative 5ab. 5b times a is going to be plus 5ab, and 5ab minus 5ab is indeed 0. So that is it. And for this one here, we could check to see if it is a difference of perfect squares. Well, what times itself is 144? What times itself is 196? 14. So these are a difference of perfect squares. So what we can say, this first one term is 14x plus 12 times 14x minus 12. Is there a common factor between 14 and 12? 2, yes? So out of the first one, I can pull that 2 out, which would leave me with 7x plus 6. 11. It depends on if the instructions say to factor completely. And in the other one, we have a greatest common factor of 2, yes? Because I can pull one out of both. I have 2 of them, which tells me I have 4 times. But I will say this, if you forget to pull out that greatest common factor, at most it's a 1 point for that problem. So out of the total, again, 4 or 5 points. So out of, like, say, 4 points, you're only losing 1 out of 4, so you're still getting over 75% of the problem. Just getting to here. Does that make sense? So even if you miss the greatest common factor, that's fine. At least be able to factor it. Because we pulled 2 out of both, yes? Yeah. Well, 2 times 2 out front is... So the actual greatest common factor we could have pulled out at the beginning was 4. Because that would have left us with pretty much 49 and 36, which is 7 and 6, which still is a difference of perfect squares. Any other questions on this here? (11) and 12 are the same thing as what we did on the first few. The only thing that makes them different is that our answer ends up being the same thing, something times itself. Because if we look at 11, no greatest common factor. So our sign, if we look at the third term, it's positive, so the signs are the same and they match the sign of the middle term. So we have negative and negative. Factors of the first and third term, well, factors of A are A and A. And it works out the factors of 196 that we want are 14 and 14. Yes. A minus 14 squared. Because 11 and 12 are both a perfect square trinomial. They end up that we could rewrite it as one set of parentheses squared. I will take either answer. Both of those are the same answer. So if you get either one of those, you would get the whole points. Because since they're the same thing, something times itself, I can rewrite it as that parentheses squared. Yeah, so if it was minus and plus, they're different.
Oh, okay. Yeah, so it goes back to the rules that we just did.
Yeah,
okay.
Anything times itself is just squared.
Yeah.
16? Because we could use the difference of perfect squares that we just had. We could rewrite it as that number minus the other, so 144 minus 64 times 144 plus 64, and do it that way. Or squared minus 64 squared. They're both just numbers. 16,640. We're just finding the value. If we didn't have a calculator, we could do it by the difference of perfect square method and find it pretty easily. We have a calculator right there. Go and type it in. I included those on the test because they're easy points. You're typing them in, simplifying, and moving on. Any other questions on these here? Solve each quadratic by any means. When it says any means, it literally means any method that we have done. Factoring, graphing, square root method, the quadratic formula, and completing the square. You can use any one of those methods to solve. So for the first one here, we could factor it. Look for a greatest common factor, which there's not one. 2 sets of parentheses with 3 spaces. Look at the sign. Since the third term is positive, our signs are the same and they match the sign of the middle term. So plus and plus. Then we look at the factors of the first and third term. Well, factors of x squared are x and x. Factors of 2 are 1 and 2. And even with solving by factoring, because again, anytime we have two things multiplied together to equal 0, one of them must be 0, yes? So I have two things multiplied together to equal 0, so either x plus 1 is 0 or x plus 2 is 0. And at this point, we just solve. Because again, there are some problems that say solve by factoring, and I might have already set them as a set of parentheses being multiplied together. You don't have to factor two of them, you just have to set them equal to 0 and solve. Yes?
So how do we know if you're wanting that answer, this two answers, or if you're wanting just the problem? Does that make sense? Like the first
Solve.
solve.
Because solve, we're looking for what value of x will make this thing equal 0. And if we look at the first few, there is no equation. It's not equal to anything.
Okay.
Yep. And again, I would always look back at the instructions. Factor the following polynomials. So it's just wanting us to factor. On some of them, it might say solve by factoring. So it wants us to use our factoring steps to solve it. If it's already in factored form, so if it started out at x plus 1 times x plus 2, set them equal to 0 and solve. Now, we could have graphed it. X squared plus 2x plus 1. Because again, when we graph, we're trying to see what value of x will make this thing equal 0, yes? Graph. So we have this here. Make sure. That's why. Because it's x squared plus 3x plus 2. And if I graph this, okay, we do see it crosses at two places, yes? If we go second graph, it pulls up a table. So at -1 and -2, the y values are 0. Because again, we're trying to see what value of x will make the y be 0, not x. Not what values x is 0, but what values y is going to be 0. So, -1 and -2. Questions on 17? Questions on 18? Yeah. Because any method, so we could try factoring x squared minus 9, type it in and hit graph. Okay, we do see it crosses at two spots, yes? So if we go second table, one of the values is, and the other is 3. Possibly, because the other way we could have done this is by the square root method, or we could have factored. Either one of those would work. And if we're going to graph, we need it equal to 0. If we're going to graph, we need it equal to 0. So even number 20, what I could do is subtract 10 from both sides to get it equal to 0. 4 times x minus 1 squared minus 8. Look back, yep, 4 x minus 1 squared minus 8. We don't have to put the equal 0 because, again, we're trying to see where y is 0. That's what the equal 0 is for. And we hit graph. Does this cross at two nice points? No. So this is where graphing falls short. And if it does say that we can solve it by graphing, they're going to give us 2 nice points. I'm going to do that to you. I'm not going to make you try to approximate numbers. It's going to give us nice points if it tells us it's by graphing. But I do have a set of parentheses squared, yes? We can use the square root method. The square root method says that we get the set of parentheses that's being squared by itself first. So the first thing I can do is subtract the 2 from both sides. If you still had it as 8, you could have added the 8 to both sides. Either one would work. Now the set of parentheses is still not by itself, so we would divide both sides by 4. Yes. Yes. Which would get us to this point here. X minus 1 squared is equal to 2. Since the parentheses mean squared is by itself, we can square root both sides, which will tell us that x minus 1 is equal to plus or minus the square root of 2. Because again, whenever we square root both sides, we do need the plus or minus. And last but not least, we add 1 to both sides. Once we get the plus or minus and we add or subtract something, we always put it in front of the plus or minus. So this here is our answer, 1 plus or minus the square root of 2. Yes, anytime you square root both sides, we need the plus or minus. Because that's part of the reason in the quadratic formula we have the plus or minus the square root there. Because if we divide it on one side, we have to do it on the other.
But I thought that you would just divide 4 by 4.
Mm-hmm. And 4 divided by 4 is 1. So we just left with the set of parentheses.
So you don't even have to bother with the x minus 1 you divide it?
Because it applied to the 4. 4 and 1 are one term because they're multiplied.
Okay.
So really what we're saying is that I have 4 divided by 4 times the x minus 1 squared.
Yeah.
And the 4 divided by 4 is 1. 1 times the parentheses just leaves us with the parentheses.
Okay.
You're welcome. If it had been just the x minus 1, then we couldn't just simplify it. It has, because of that multiplication is why we can do that. Any other questions on this here? Questions on 21 or 22? All right. Well, 21 will be the exact same thing we just did. So if we have time, we could come back to it. I want to make sure we get to the other stuff first. Also, if we don't, I do have it on the video. Now, this one here is going to be using the completing the square. Now, interestingly enough, let's go on and just look at 24 and 25 with actually completing the square. With actually completing the square. Either one of these in particular that y'all want to look at. If not, I'll just go on and do 24. They're both the same. Now, the only difference with 25 is that the constant term is already by itself, yes? And with completing the square, that's not an issue, because if we remember step 2 is to get the constant term by itself. Because our first step is a equal to 1. Well, here a is not 1. If not, make it so. So we have to divide everything by whatever that a value is. Since here it's 2, we have to divide everything by 2. And 2 divided by 2x squared is just x squared. 12x divided by 2 is 6x. And 24 divided by 2 is 12. Okay, that was step 1. Step 2 is to get the constant term by itself and leave 2 spaces. So what we can do is add 12 to both sides, which gives us x squared minus 6x plus blank equals 12 plus blank. Now that brings us to our third step, is to find the value of c, because we're trying to make this into a perfect square trinomial, one set of parentheses being squared. And our c value is b over 2 squared. Now the value of b in this case is negative 6. And negative 6 squared, well, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. And again, remember, the value of c is always going to be positive. The value of c is always going to be positive. Our next step is to factor it and solve. X minus 3, because what goes inside the parentheses is whatever we have when we're trying to find for c before we square it. So what's inside that parentheses before we square it was negative 3. So it's what goes in the parentheses here. And 12 plus 9 is 21. Now we're essentially back to the square root method, because we're going to square root both sides. And when we square root both sides, here, the square root and square will cancel, leaving us with x minus 3 is equal to plus or minus. In those yellow calculators, I will try simplifying the square root of 21. If it had been negative 21, I would pull the I out, take the square root of 21, see if it reduces. And it'll tell us that, well, the square root of 21 is still just the square root of 21. It doesn't simplify at all. Yeah, there is no perfect square factor. A number times itself. So 4, 9, 16, 25 aren't products that we can get to 21. So we're just left with this here. But the last step is still to get x by itself. So x is equal to 3 plus or minus the square root of 21.
We do have now, you like us to put it at the end, right?
Put it before the radical.
Oh.
And again, the reason I say put it in front is just to make sure that y'all don't put the I inside, back inside the radical. So we don't have square root of 21i, every 21 and I being inside. If it depends, I'd have to look, because I was kind of leaning on most of them, unless it was blatantly obvious that you stuck it inside. Because what that's saying is that you have the square root of, like this here, is the square root of 13 square root. It's negative 1. That's really what it's saying when it's back inside. So we normally put it out front just to make sure that we don't have that. Yeah. If it's off to the side and it's clearly outside, that's fine. I just don't want you putting it back inside. Yeah. Any other questions on 24? The bonus might be completing the square, but we don't get nice numbers when we divide, because it could be one that we've seen already where we get fractional answers. Process is still the same. It's still the same process. We just have fractions instead of nice numbers. Let's look at the next one. So this one here, it wants us to solve by the quadratic formula. Do we want to look at 26 or 27? 27. In either one of these cases, if we can keep a positive, it makes things work nicer. Here, we can add 4x squared to both sides. Because again, when we use the quadratic formula, we do need this equal to 0. When we use the quadratic formula, we need it equal to 0. And by adding 4x squared to both sides, we get 4x squared minus 7x plus 6 is equal to 0. If we had negative 4x squared, we could divide or multiply by negative 1 to just flip the signs, and it'll give us the same answer. And again, this is lining up with our ax squared plus bx plus c. And for this first part here, so we have negative b. Well, b in our case is negative 7. B squared, negative 7 squared, minus 4. A in our case is 4. So we negative 4 times 4. And C is positive 6, all over 2 times A, which is 2 times 4. So with the quadratic formula, I'm just typing it in. I'm plugging in the values for A, B, and C. And the signs that are in front of them will go with them. Well, negative 7 is 7, yes? Plus or minus 4 times 2 is 8. Because luckily doing those two are not too bad. I don't need a calculator for the most part to do those because the numbers aren't too big. Negative and negative makes a positive. 2 times 4 is 8. Inside the radical, I always type what's inside the radical first. I don't type it with it. So we have negative 7 squared minus 4 times 6. So in the graphing calculator, parentheses, negative 7 squared minus 4 times 4 times 6 is negative 47. Because if we did type second square root, negative 7 squared minus 4 times 4 times 6, we get this decimal with I. So if we have it in A plus BI form, it will simplify it, but it gives us an ugly decimal, so that's not as nice. If we had typed it into the yellow calculators with the radical, it would have thrown it out as non-real answers because there is no such thing as the square root of a negative number. But what we do know, if there's a negative inside the radical, it comes out as I. So I'm going to pull that negative out as I. Which leaves me with what? The square root of 47, yes? I would grab that 30xs, take the square root of 47, hit enter, and see if it reduces. And well, it's just going to throw back the square root of 47. There is no perfect squares. I want you to get at least to here. I will take off points if you leave it as the square root of negative 47, because luckily that's not too bad. It's just pulling that negative out as I. If there is a chance that it does simplify, there's a greatest common factor to reduce, and you notice it go on and reduce, but I want you to at least get here. Okay? Any other questions on this here? So we good with quadratic formula? Yes? And again, if you get stumped with completing the square quadratic formula, factoring, solving by factoring, and you can know how to do it by a different method, go on and do it by the different method. Get the answer, and you'll just give up the 1 or 2 points for doing it by the wrong method. But if you can at least get the answer, get the answer. Does that make sense? Any other questions on 26 or 27? Find the value of the discriminant and describe the type of solutions. I'm not going to make you find the values of the solutions on the test. I just want you to find what it is and what types that we have. Because if b squared minus 4ac is greater than 0, we have 2 real solutions. If b squared minus 4ac is equal to 0, we have 1 real solution. And if b squared minus 4ac is less than 0, we have 2 complex or 2 imaginary solutions. So there's really 3 answers to this here. the value of b squared minus 4ac, the number of solutions, which is either 1 or 2, and what are they? Are they real or complex? So there's 3 parts to this. Now, if we look at the first one, any of these here, it has to equal 0. It has to equal 0 so that we get the correct sign. So if we just look at the first one here, I can subtract 4x squared from both sides. B squared minus 4ac. Now the value of b in this case is 5. So we have 5 squared minus 4 times a is negative 4 times c is negative 10. Yes? Plug it in. B squared minus 4ac, that's all numbers. We don't need the radical, we just need to find out what this value is. So we have 5 squared minus 4 times negative 4 times negative 10. Enter. We get negative 135. There's one answer. Because it wants to know the value of the discriminant. It wants to know what the value of b squared minus 4ac is, which is negative 135. Well, is that greater than 0, equal to 0, or less than 0? Less than 0. So this is too complex. That's it. That's all it wants. That's all I'm asking for on the test. I'm not asking you to actually solve it. I did include solving for those 3 on the answer key, but on the test, that's all I want. Any other questions on these here? We good with 28, 29, and 30. And again, when you're solving these here, make sure they equal 0, because that could cause a sign difference. Because if you just plugged it in at the start for 28, you'd have plugged 4 in as a's value in as positive 4, not negative 4. Because we didn't move it over. Does that make sense? Because again, we need it equal 0. We need everything on the same side. Any other questions on this here? Okay. Create a perfect square trinomial by finding the value of c and factoring it. Well, c is what? B over 2 squared, yes? I'm just going to do number 31. C is equal to b over 2 squared. Well, what's the value of b? So we'd have negative 24 over 2 squared. Now, if it doesn't divide evenly, leave it as a fraction. You don't have to put it as a decimal. I'll take it as a decimal, but we can just leave it as a fraction. Negative 24 over 2 is negative 12. Negative 12 squared is 144. So what's the value of c? 144. We could rewrite it as x squared minus 24x plus 144. But we still need to factor it. And since this here is a perfect square trinomial, it's going to be rewritten as one set of parentheses squared. We're going to have x in front. And again, the number that goes with it is whatever we have inside the parentheses before we square it, which is our minus 12. That's it. That's all it's asking for. Any other questions on these 3 here?
So you don't want us to plug it back in. Like, we don't have to do that.
For the bottom part?
Right above it.
Yeah, this here is not necessarily necessary, as create a perfect square trinomial by finding the value of c. So I will take it, but the main thing I'm wanting is c, making sure you can find c and factor it. Okay? That's fine. If you want to make doubly sure that you got it, go on and just write it out. Because it doesn't take too much time to put it back in. Yeah, when we square it for this one here, it's always positive. You're good. Any other questions on this here? We good with this here? All right. I. And again, remember with I to a power, there's only one of four answers we can have for these here. I, -1, -I, and 1. Those are the only four we can have. And really, we take whatever the power is and divide it by 4. If we get a decimal 0.25, it simplifies to I. 0.50 is -1. 0.75 is -I, and 0.00 or no decimal is 1. So for all these here, you're typing it straight into the calculator. Any one of these in particular that y'all want to look at? We can do D, I to the 2,847, or 2,874. 2,874 divided by 4. 0.5 is -1, so this is -1. We don't care about the number in front, the whole number, we just want the decimal. Decimal's point. So 6971 divided by 4. 0.75. If it gets a decimal 0.75, it is -I. If there is no decimal, it is 1. Because if it comes out even, it gives us 0.00. The calculator does not include a decimal because it's not necessary, so it's just going to be 1. So if you just get a whole number, no decimal, it is 1. Questions on these here? These we can type into the calculator as they are no changing in them at all whatsoever. So the first one, 6, if one of y'all can read it off, 6 what? 7. I. That's it. Even if it has to the 4th power, to the 6th power, type it in exactly as it is. Enter. 10 minus 10i. That's it. Addition, subtraction, multiplication. We type it in exactly as it shows up, and the calculator will do it for us. Now, the ones that I specifically want to look at, because we're almost out of time, the division ones, I won't write it out. I won't go through the process of typing it in. We can. But here, remember, we have to rewrite it out as in parentheses with our division. So 8 minus 4i divided by 3 minus I. So 8 minus 4i divided by 3 minus I. And again, when you do this, make sure to put the numerator and denominator, top and bottom, in parentheses. Now, to get it out of a decimal, we go math, enter, enter. That's your answer. 14/5 minus 2/5 I. Questions on this here? And again, I went through, if you want to go back and look at the steps, I do have these all stepped out on that video. The last ones I want to look at are on the back, because I'll have to grab a review sheet quickly, is the complex conjugate and multiplying to find its value. So go on and hang on with me for a second. Now it asks to find the complex conjugate of 4 minus 3i. Well, what is its complex conjugate? We're just changing the sign in front of the term with I. And to find its product, we multiply the two together. And again, with multiplication, division, subtraction, all that can be done straight in the calculator, yes? So you could type it in as 4 plus 3i times 4 minus 3i, and you'll get 25. The product of two conjugates is always going to be a number. We will not have I, with complex conjugates being multiplied together. But that is it. Hopefully there's no other questions on any of the